All right, so real quick update on the blinking iris goggles project. I'm waiting on some code. However, I've taken the time to go ahead and put some LEDs, and I've got some red LEDs and I've got some infrared LEDs, so I can either stick with a red light or I can go with an invisible light, whichever one works. I just was playing around with the red ones and they look really cool. If I can keep the red ones, then I think that's gonna be the way to go. I just really quick wanted to show you what they look like with the red ones on. The goggles right now, the code is set up to be triggering off of a photoresistor. So right now I don't have all the electronics hooked up, and like it just like blinks on and off a ton. That is not going to be what the ultimate design is. The ultimate design will be triggering the blink off of whether your eye inside the goggles is open or closed. So just bear with me. This gets kind of annoying because it just goes a ton, but you will get the idea as far as the red LED is pretty slick. So let me plug this in. The noise is pretty terrible, sorry, but the payoff is huge. All right, I'm gonna turn these lights off so you can see. Almost, there we go. All right, so that's kind of what we're looking at. Kind of crazy cool effect. The LED is on the inside like that, so it's where the eye is. And yeah, so it's just kind of on the fritz because of the photoresistor not being properly set up right in the code. But even with the lights on, it still makes a cool eye effect. Like you can still see the red inside. So like during the daylight, you should still be able to see the red tint on the eyes. So yeah, I guess I'll go ahead and move on from that. Y'all get that. So I can show you a little bit more about the electronics and what I'm working with. Let's take a look here. How am I going to do this? Let me turn the lights on. All right, I'm going to move this. We're going to swap camera around so you can see the bench. Bear with me, sorry. Is that gonna work? That's good enough for now. Okay, so basically I give you a rat's nest of wires. I've got so much going on here. Well, it's actually not that much. This one is just powering the LED, the red one, so I can unplug that because I don't need that now. And then this board over here is the photoresistor that I've been playing with. This is the DigiSpark, and then I'm just powering the DigiSpark with the 5 volts from my power supply. And then I'm pulling the PWM signals from the DigiSpark going through these cables to the servos. Now this is the first photoresistor that I started playing with. This is something that I have used before in the past, this style. And what I ended up doing was going online and looking for a LED photoresistor set. And these are the ones that I linked to in the description. These are infrared LEDs, so there should be no light being emitted as far as like what you can see with your eyes, visible light. And these are the sensors. And what I was doing is I was testing this earlier, and it looks like both of these are similar as far as how they work. So that's cool. It is interesting though, this looks very much like an LED. Even one leg has like the longer link for like the anode. And I figured if it's a resistor, then it shouldn't matter which orientation I put it in. And I could be totally wrong, but it seemed like it works better whenever I put the shorter leg going towards positive. So I'm probably super confused on this. I'm going to get things sorted. I'll show you real quick kind of what it does. So I plug that in. I'll supply 5 volts to this rail. So now I'm getting 5 volts here, which goes through the photoresistor to a resistor junction. The resistor is pulled to ground, and then the other portion of that circuit goes to my multimeter. And so I've got my multimeter connected from ground to this center junction here. And then I'll just turn this on and show you. Man, this is a mess. Sorry, I need to figure out how to better do all this. Okay, so let's go. Okay, so right now we've got basically an open circuit because my lights are hitting this, but if I cover this, you can see the resistor value changes to about 400 mega ohms, around that. And then if light hits it, it jumps back to no resistance. So that's good. Or is it no resistance, or is it totally resistant? I'm gonna have to, again, I'm kind of working through this. I just got all this stuff in and started playing with it this morning. But that's kind of the mechanism that I'm working with to get it to trigger. And what I'm hoping is that I can get this light sensor to maybe mount on the inside of the iris box, so that whenever I blink, the reflection of my eye reflects less. Or I don't know, I'm gonna have to play with orientation, but you can see here better. I just have, it's really simple. I think this actually worked out super well as far as illuminating the eye. So I'll probably just clean this up and then wire everything internal and do one red here, or an infrared, whatever, on this side. And then I've drilled some holes. I've got, you can see permanent marker markings reminding me of the edits that I'm going to do to the frame to allow more space for some of the components. But once I wire everything in, then we should be able to rock and roll. But like I said, I'm still waiting on some of the code aspects. But once we get those in, we should be able to make some really good progress on this. I'm pretty excited. It's going to look really neat when it's all done. All right, let's take a look. Are there any comments? No comments. All right, well, I'm going to go ahead and wrap up this live stream. I don't really have much else to show you besides a bunch of wires and some goggles that have permanent marker written all over them. So just stay tuned, and hopefully I'll be updating a video pretty soon with proper code and with all the electronics installed. And my end goal is to be able to blink and have this one independently blink with that one. So this should be pretty sweet when it's all done. All right, thanks for joining, and I will see you next time.